In the simple smart home system we designed, the DC-regulated power supply is the energy guarantee for the normal operation of all modules. Therefore, the topic of this lesson is design of DC-regulated power supply circuit. Through this lesson, we will know the composition of a DC-regulated power supply circuit and be able to select the correct components based on actual needs. The focus of this lesson is the composition of a DC-regulated power supply circuit. The difficulty lies in correctly selecting the component models. In this lesson, we will design a DC-regulated power supply circuit with an input AC voltage of 12 volts, an output DC voltage of 5 volts, and a maximum output current of 3 amperes. The DC-regulated power supply circuit is composed of 3 main parts: the rectifier circuit, the filter circuit, and the voltage regulator circuit. The role of the rectifier circuit is to convert AC voltage into pulsating DC voltage. Pulsating DC voltage means that the voltage, or current, polarity, direction, remains constant, but the magnitude varies with time. The role of the filter circuit is to convert the periodically varying pulsating DC voltage into relatively stable DC voltage. The role of the voltage regulator circuit is to maintain a stable output voltage even when there are changes in the input voltage, load, environmental temperature, and circuit parameters. Having determined the composition of the power supply system, we also need to determine how to achieve the desired circuit function. The rectifier circuit can be a bridge rectifier circuit, which consists of 4 diodes and utilizes the unidirectional conductivity of the diode to rectify the current. It is widely used in electronic equipment, power systems, industrial control, and other areas. It works as follows. During the positive half cycle, the transformer outputs voltage with the top positive and the bottom negative. Diodes D1 and D3 become conductive, allowing a current path to form from the top positive terminal, through diode D1, the load resistor RL, and then back to the bottom negative terminal through diode D3. During the negative half cycle, the transformer reverses its output voltage, with the bottom positive and the top negative. This configuration enables diodes D2 and D4 to conduct, establishing a current path that flows from the bottom positive terminal, through diode D2, the load resistor RL, and finally back to the top negative terminal through diode D4. It's evident that whether it's the positive or negative half cycle of the AC sine wave, the current direction across the load resistor RL remains the same, converting the AC voltage into pulsating DC voltage. Filter circuits include filter capacitor circuits, filter inductor circuits, and complex filter circuits. Among them, the filter capacitor circuit has a relatively simple structure, higher load voltage, and lower ripple. Therefore, a large capacity electrolytic capacitor is used to complete the filtering task. A capacitor can store electrical charge. When the voltage increases, the capacitor absorbs charge to stabilize the voltage. And when the voltage fluctuates downward, the capacitor releases charge, mitigating voltage changes and converting pulsating DC voltage into a more stable DC voltage. A voltage regulator circuit can be implemented using a 3-terminal IC voltage regulator, which has only 3 pins: input terminal, output terminal, and earth terminal. The internal circuit includes protection features for overcurrent and overheating, as well as adjustment components. With fewer external components required, it is user-friendly and offers stable performance. Now, we have established the basic framework for the DC-regulated power supply circuit. After establishing the basic framework of the circuit, it's essential to correctly select the components to complete the final design. The voltage regulator circuit is a critical part of the design. So we should first choose the 3-terminal voltage regulator and then determine the appropriate peripheral circuit according to its technical manual. The maximum output current and voltage of the 3-terminal voltage regulator should be selected based on the power consumption of the smart home system. Calculations indicate a need for a maximum output current of approximately 2 amperes and an output voltage of 5 volts. Therefore, we choose the LM1085-5 as the voltage regulator chip for the power supply module of this system. A 4700 microfarads 35 volts electrolytic capacitor is selected as the main filter capacitor. A 1000 microfarads 25 volts electrolytic capacitor is selected as the filter capacitor at the output terminal of the voltage regulator circuit. And a 0.1 microfarad monolithic capacitor is used for high-frequency filtering. Based on the maximum current of 3 amperes and the peak voltage of 12 volts in the rectifier stage, we choose the diode 1N5822 for the rectifier circuit. After determining the component models to be selected, the design of the DC-regulated power supply circuit can be completed. Through this lesson, we have learned that a DC-regulated power supply circuit consists of rectification, filtering, and voltage regulation. Additionally, we have grasped the basic principles and methods for selecting components. That's the end of this lesson. Thank you for watching.